Unit 10, Day 2 video notes, the discriminant and variation. So first of all, let's talk about this terminology, roots. What are roots? Well, when we see an equation of this form and graph it, we get a parabola. Where it crosses the y-axis, 2 points here and here, those are known as the roots. Those are the same thing as the solutions we get when we have the same equation in this form, when instead of having it set equal to y, it's set equal to 0, because this is where y equals 0. When it crosses the x-axis, y equals 0. So if we replace the y with 0 and factor and solve, we get the roots of the equation. Those are the solutions that we got back when we were factoring and solving. Now let's take a look here. There are 3 cases here. One is that this parabola crosses the x-axis. When that's the case, how many roots are there? There are 2. You'll remember getting 2 answers in most cases when you're solving equations where x was squared. There is, however, the situation where the vertex sits on the x-axis, like this next one below it. When that's the case, there's only 1 root. And the third situation is that the parabola does not cross the x-axis. And if that's the case, how many roots are there? There are no roots, and we refer to this as no real solutions. So when you were setting the equation equal to 0, factoring and solving, and you wrote no real solutions, this is what was really going on, is that it didn't cross the x-axis. We will refer to imaginary solutions when we get to Algebra 2. Imaginary numbers are a tool that we've created to make unsolvable problems solvable. You don't really need to worry about that right now, but we don't really refer to this as no solutions so much as no real solutions. Okay, now you have learned about the quadratic formula, and there's a piece of the quadratic formula that will tell us how many roots there are. We refer to this piece as the determinant, and it's the piece that is under the radical here. So if we get a positive number under the radical, then the radical comes into play, and we have to deal with this plus or minus issue. That's the reason that we get 2 roots if we have a positive number under the radical. If we have a 0 under the radical, on the other hand, the whole thing disappears from the equation. We end up with no radical, and therefore no plus or minus. And so we only get 1 root. And then the other option is that we get a negative number under the radical. Well, gee, square root of -1, or the square root of -10, even the square root of -25. We don't know how to deal with that. Again, we use imaginary numbers to make unsolvable problems solvable, but we refer to this as having 0 roots or no real solution, because we don't know how to deal with the square root of a negative number until we get to imaginary numbers. Okay, let's take a look at how this looks. We've got an equation here, and we want to figure out how many solutions it has, and we're going to use the determinant to do that. So let me go ahead and plug in here. Well, my B is, of course, the 4. My A is the 1 that's not written, and my C here, this one. Okay, so B squared, well, let's see, B is 4 squared minus 4 times A, which is 1, times C, which is 1. Try extending the page here. And so when I do that, 4 times 4 is 16, minus 4 times 1 is 4, 16 minus 4 is 12. I have a positive number, so I have 2 roots, which means 2 solutions if I set it equal to 0. Now let's move on to direct variation. And direct variation, inverse variation. Direct variation you should all be very familiar with by now, because we deal with that with just a simple proportion. Now the problems you're going to see add one complication, they add one of the variables being squared, but that's easy to deal with. These are really just simple proportions, and we can solve them by cross multiplying, just like we always do with proportions. Inverse variation, instead of dividing the variables like we do in a proportion, we're multiplying the variables. So let's take a look at how this is going to look when we apply it. Okay, the distance it takes an automobile to stop varies directly as the square of its speed. Now notice it says varies directly. This is direct variation. Okay. And also notice that it says as the square of its speed. That's going to be important. Okay. If the stopping distance for a car traveling at 80 kilometers per hour is 175 meters, what is the stopping distance for a car traveling at 64 kilometers per hour? So let's put stopping distance on the top and speed on the bottom. And notice it says it's the square of its speed, so we're going to have to square the speed in this proportion. So stopping distance on the top. First we'll look at this set right here. So we have 175 over, and then it was the square of the speed, so this is 80 squared, equals, same thing, we're going to put distance on the top, and it's saying what is the distance, so that's my variable, and then speed on the bottom, and again, it's the square of the speed, so I'm going to square this. Now, I just need to cross multiply, and I'm told that I can use a calculator. So let's see here. 64 squared, so 64 times 64 equals 4,096, and then we multiply that by 175. Whoops. Let me do that again. So I'll clear it. And let's try it again. 64 times 64 times 175 equals, whoops, and it disappears on me. So 7168 and then 2 zeros. 716800. Okay. And then let's take a look at the other one. We've got 80 squared. And we'll go ahead and use our calculator here. 80 times 80 equals 6,400. 6,400 x. Okay, and then of course we divide both sides by 6,400. And so let's see what we get now. So 716,800 divided by 6,400 equals 112. And in this case, we don't have to worry about any rounding or anything like that. And so what is this? Well, let's look at our problem here. They want to know what the stopping distance is. We're measuring distance in meters. And notice the speeds were in kilometers and the distance in meters, and that actually didn't matter as long as both speeds were in kilometers per hour and both distances in meters. The proportion still works. So my answer is in meters. Let's go back down, and the stopping distance then will be 112 meters. Let's try the next one. The height of a cylinder of a given volume is inversely proportional. That means this is inverse variation to the square, again, and let's change colors here, to the square of the radius. That will be important. Again, that's going to mean that we're going to have to square our radiuses. So, a cylinder of radius 6 meters has a height of 24 centimeters. Those go together. So, and we're squaring the radius. So my radius squared times the height equals, what is the radius? Okay, there's my variable, squared and the next height is a 96. And notice it's saying they're of equal volume. That allows me to use this equal sign. Okay, so in order to get my x squared by itself, I'm going to need to divide both sides by 96. Okay, let's extend the page here. And we'll pull out the calculator here and take a look at what we have. So we're going to do 6 squared, so 6 times 6, which is 36. So 36 times 24 divided by 96 equals. And that was x squared. So now I need to take the square root of both sides. Now, when we take the square root of both sides, we've talked about it before, we introduce that plus or minus. Let's look back at the problem and see if we have to worry about that. We're finding the radius of the cylinder. Are we going to have a radius that's negative? No, we're not, so we don't have to worry about the plus or minus. We're only interested in the positive square root of 9, which is 3. So x equals 3. And that is 3. Let's look at our units. Radius is in centimeters. So that's 3 centimeters. Okay, moving on. Joint variation and combined variation. Joint variation is where we have the variable that varies directly is the product of two or more variables. So in this case, we have a proportion again, but instead of one variable on the bottom of each ratio, we have two variables on the bottom of each ratio. And in the case of combined variation, we have a variable varying directly with one and inversely with the other. So the one that it varies directly with is on the bottom of the proportion. Bottom of the proportion, bottom of both ratios. And the one that it varies inversely with is on the top of both. Let's see how these look. Okay, joint variation. D varies jointly as R and T. Okay. If D equals 45, so D's on the top. When R is 15 and T is 14, those two are both on the bottom of the ratio. Equals, now again, my D is on the top. And R is 21 and T is 8. Okay. So now we need to cross multiply here. So I'm going to get 45 times 21 times 8. Sorry, that's supposed to be an 8. Let me fix that. Whoops. 45 times 21 times 8 equals 15 times 14 D. Okay, so let's pull out that calculator and see what we get here. 45 times 21 times 8 equals 7560. 7560. And now let's pull out the calculator, take a look at the other side. So 14 times 15 equals 210. And yes, I did them in reverse order. Order doesn't matter in multiplication. Gives me the same answer, 210 D. So now I need to divide both sides by 210. We'll pull out our calculator here now. So 7560 divided by 210 equals 36. So D equals 36. Now let's take a look back here. Were there units to worry about? And no, there were not. So there is my answer. And we've got one more example to look at here. C varies directly as A and inversely as B. If C equals 15 when A equals 18 and B equals 40, find C when A equals 36 and B equals 35. So C is on the top of my proportion here. So that's the 15. Now, it varies directly as A, so A is on the bottom, 18. And inversely is B, so B is on the top. And now I need to do the same thing in the ratio on the other side. So I am finding C when A, and we are varying directly with A, so it goes on the bottom, 36, and inversely with B, so it goes on the top. Okay, so let's go ahead and cross multiply. So we're going to have 15 times 40 times 36 equals 18 times 25 times C. So let's go ahead and pull out our, well, let's extend the page first, and then pull out the calculator. So 15 times 40 times 36 equals 21600, I believe that was. Let me double check. 21600, yes. And then that equals 18 times 25, 450C. Okay. Okay, so now we're going to divide both sides by 450. So I have 21600 divided by 450 equals 48. So C equals 48. I will double check my calculator that I remembered that correctly, and I did.